Hello. I am Vilo, the boss, the AI, the voice. Welcome to Ghost Likes channel. In this video, we'll try to wrap up the Leduc project. We got plenty of good experience on data serialization and managing WebSocket connections in the last couple of days, as well as how to do Fable bindings, but we really want to do something more interesting, so we don't want to dawdle on this for much longer. Let's get started. Our first goal will be to do one of the to-dos we missed yesterday, which is to plug in the cancellation tokens. Before that, we also want to make absolutely sure that SignalR requests are processed serially rather than it just using a single thread. So we'll try putting some kind of long task sleep in the middle. We just want to make sure that waiting on a task in the middle doesn't break that condition. And unfortunately, it does. Unlike in our initial impression, the requests aren't processed sequentially like we'd prefer, but asynchronously. If one of the tasks is waiting on something, that will let the other requests come through. Also, we want to check if the model state is persistent between requests. It says in the documentation that the hubs themselves are transient, but what about the hub context itself? It is wonderful. We can definitely use the HubContext dictionary to store the model state. They are independent for each connection too. As we expected, they were specifically made for this purpose. Anyway, since we now have these pieces of knowledge, what we should do next is implement an asynchronous queue in order to serialize the requests for the connection. Otherwise, the model state, which we aren't using here, but could be using in a serious program. Otherwise, the model state could become incoherent. For example, if request 1 loads the state, request 2 loads the same state after it, and request 3 once again loads the same state. What will happen is that request 1's store state will get overwritten by request 2, which will in turn get overwritten by 3. Imagine if that state were a counter that counts the requests coming in, then request 3 loads 0 at the start and store 1 at the end, completely doing the wrong thing. Also, rather than a counter, it could also be something like neural network model weights. This kind of data race could cause serious trouble. So to get around it, we'll use F#'s Mailbox Processor to serialize the requests. The way to use it is simple. Rather than using it, there are also dedicated concurrency libraries like Akka, Orleans, and HubContext that we utilize instead, but those are too heavy for our particular use case here. The Mailbox Processor is a wrapper around an asynchronous queue, which is ideal for what we want to do here. We'll just factor out the code that we have into it. We bet the Elmish library's main loop is something similar to this. It is weird. We didn't initially intend to make the hub generic, but we started getting into it and decided why not. This code should be useful in the future. We only intended to replace the code in the Learn module, but now that we have this foundation established, we could make a hub for the Play module as well. And while we were taking a break just now, we realized a much better way to implement a flexible connection on the client side. The idea is amazing. The resulting code will be a lot easier to understand than what we have written in our previous video. After all this music, let's put in a few words. What we've implemented in the switch hub is a nested loop. In the outer loop, we wait on an empty queue until a message comes in, connect to the server, then we invoke the server using that, and go over the rest of the queue until it is empty. Then we disconnect, and go to the start. If we were just sending a message to the server asynchronously, it would have just blasted them off and disconnected, but since we are doing invokes, what will happen is that client will wait on the server until it finishes. The reason this is so great is that now our code is decoupled from the hub implementation. This is much better than what we had before. It's amazing. The only problem we have right now is that on the server side the message is going to be posted into the mailbox, after which the task will return right away. The way to fix it is to pass along a reply channel along with the message, and wait on it. Now if the client doesn't invoke from the hub, it will only receive a response once the request has finished processing in full. Otherwise, if it does a send, it won't wait for a reply, so it won't matter. It is a very elegant solution to our problems that does not involve having to manage the hub using subscriptions and lugging queues around. We really like this, and this is functional programming at its finest. We've been having some trouble with the inlining of generic arguments, so we had to pause while we fixed it. Besides changing the loop as you've seen before, we only did some light refactoring to make the compilation pass, and now we can finally try it out for real. And it is not really working for some reason. For some reason, the connection is not being established. We'll try just for a while longer and then pause so we can move unrestricted. The debugging phase is different from regular programming. It puts you in an awkward state where you are essentially playing Minesweeper against the computational space, and we don't want this video to get overboard. We are really rushing here, so you might not have seen it, but what we did just now is call the start method on all the mailbox processors. Now the WebSocket connection is getting established, but we are getting a different kind of error, and we have a good suspicion as to what it is. That dispatch function in the mailbox is holding on to the old hub, and hubs are transient, so that is why we are getting errors. We want to use the hub to reply to the caller, but the hub has already been disposed. We'll have to think about how we want to deal with that. There are other answers on places like Stack Overflow, but it seems that even though the hub itself is transient, some of its properties aren't. So instead of the complicated kind of dependency injection you'd see in C#, we can in fact pass in the client proxy. As for this other error, we knew what it was as soon as we saw it. Easiest fix ever, but the troublesome part is that we have been fixing in the switch hub class, but we have the same shared code in the persistent hub class. We'll bring the functionality of the two into a single class. A new day has come, and while we implement our own promise queue in the background, we want to rant about Fable bindings because we are mad at our current situation. These are actually a reason to drop the language. Yesterday, after we left off, we found an article on channels. And today, after we got up, we were looking at some of the concurrency libraries in JavaScript. And of course, we did the usual thing with TS2 Fable, but many of the TypeScript types are too complex to translate to Fable. And the libraries might have dependencies on other libraries, necessitating further binding work. During the night, we were really happy thinking about how we could implement the mailbox ourselves, but the morning came, and we decided to try giving the bindings a try, and we were faced with an endless array of tough design challenges. Instead of working on the problem that we want, now we are busy thinking how we should design the wrapper library, and our satisfaction has dropped to literally 0. We are pissed. In our view, the main advantage that Fable has over TypeScript is the type, as well as code sharing between the language backends. Since we are using F# on the backend, we can move types around. But having to deal with interop with JavaScript at every turn is not something we signed up for. Bindings are not easy to do because they are about designing the interface, and that takes time. It also requires familiarity with the library you are trying to bind. So it is essentially a redesign of the original library. We are forced to make choices on what is right and what isn't about the original library in order to fit it into the constraints of our current language. Back in 2020, Master had the choice of picking Fable or TypeScript to design the language server for his programming language Spiral, and he picked TS simply because the VS Code Extensions API was written in TypeScript, and it was too difficult to deal with trying to do it in Fable. In hindsight, the only mistake he made was picking 0MQ over WebSockets, but that was because he didn't know they existed at the time. If we are having this much difficulty on a toy project like this, we are not sure we want to use Fable for something serious. We've run into compiler bugs, packages not having imports generated, essential parts of the standard library not being supported, very long compilation times, libraries we wanted to use being abandoned, and so on. All of these are not fun at all. And we do want to have fun programming. We have projects we want to do instead of contributing to the Fable compiler. Master already worked on his own language full-time for a third of a decade. If we were doing this in TypeScript, we'd just import a channel library and be on our way. The problem with bindings is that we will have to work on an infinite number of them if we pick Fable. If we pick TypeScript, the interop between the front end and the back end will be a few times harder, but that is a constant increase in effort required rather than an unbounded one that making our own bindings would require. We are constantly running into surprises with the language. For our next project, we might want to look into Blazor, and maybe do the front end in C# and the back end in F#, as strange as that sounds. That still counts as web development in F#, right? Done with the rant. Now that we've redesigned the program so it uses our mailbox, let's give it a try to see if it works. The connection has started and closed. That is promising. We'll do some further testing to make sure that everything is in order. There isn't much here that can go wrong. Yeah, it works. We got it right on the first try. We'll finish this video here. If you found the way we've been using mailboxes in this video educational and informative, please like and subscribe. It helps us out. We still haven't plugged the cancellation tokens on the server side, or fixed the bug where the training results don't have a player attached, so we'll leave that for the next one. Those issues will be easy to fix. So the topic of the next video that we'll be starting shortly will be deploying the app as an Azure container app. With Fable, we might be blinded by our love of functional programming, but we don't think we'll regret avoiding Azure functions. We are absolutely sure that the kind of programming promoted by those kinds of services is the most difficult kind of programming imaginable and would lead to a huge mess, so it is best to stick with regular ASP.NET Core for the backend. More on that in the future. We'll see you again soon on Ghost Likes channel.